So 6.4, we're now going to introduce logs or logarithmic functions. We're going to split it up into 2 days. Before we get into what logs are and how those work, we're going to review something pretty basic and then introduce something we haven't done, but we're going to do it with the calculator so that we can get an idea of how that's going to play out. Okay? Take 10 seconds, maybe 30, and do A and B real quick, because there's going to be some inequality solving that we're going to need to be able to handle. Okay, so just to review, to solve basic inequalities like these where you just have an x, not x squared, or right, you just get it alone. So what did you do here? Plus 8, and then? And so you should have gotten x is less than 8/7. This one, a little bit more complicated, but not too bad. What did you do first? So I heard two different things. I'm going to do them together. I heard add 12 to both sides, so I get 16 on this side, and I also heard add x to both sides, so now this becomes 4x. Everybody good with that? And then divide it by 4, so now x is less than or equal to 4. Okay. This is something that in its own, if we wanted to do without a calculator and all, we could really spend 2 days just on these types of questions. We don't have that luxury, but we are going to see some of these within logs. Okay, so we're going to talk about how these work. To start, go ahead and take the left-hand side of this and put that into y1 on your graphing calculator. Okay, we all knew it was going to be parabola, but now we have more of an idea of what it looks like. Everybody getting the same picture roughly? Okay, go ahead and find those zeros. Remember how to do that in the calculator? I mean, we could pretty much see them, but just make real sure that that's what they are. -3 for the one on the left. And then 4, okay. And so, picture looks something like this, right? All right. Now, if we take a look at the inequality, we want parabola, that's what this is, right? We want it to be smaller or equal to 0. Where on this parabola is it less than or equal to 0? On the left? I would agree with that one. If we go to the left here, we are above 0, right? This section here, this is where the parabola is less than or equal to 0. You guys see what I'm talking about? Remember, this is y, these are y values, right? So if we're talking about y equals 0, we're looking for the part that's underneath the x-axis. Does that make sense? If I asked you to tell me what x values those are with an inequality, how would I say x is between? So, do you guys remember doing these compound inequalities like this? Okay. Between -3 or equal to, and same with the 4. Okay. Now, very important, okay? Try B. See if you can get that one on your own.
That was the answer.
Yeah, that's all we need to figure out is what x values are we below or equal to 0. Here, a little different but similar. What x values are we above 0 now? You guys getting the same picture roughly? What are the zeros? So -2 and -3 are the two zeros, okay? And now if we want to be above 0, so we don't want this anymore, right? But we want this part and the other side over here. These two parts of the parabola are above the x-axis. That's what this means. Okay? So now how do I say what these numbers are? Where are we? Are we to the left or to the right of -3? To the left. So what does that translate to? X is less than, and we don't want to say equal now because it's not equal to start. It's just, right? Or, what do I say with this part? X is greater than -2. Okay? Those are pretty much the only two scenarios you're going to see. You're either going to be between values or you're going to have two parts of the parabola that work. And you just need to write down which parts it is that you want to include. Does that make sense?
Why go inside the last number like the equal to?
Well, because at the very beginning, it's just greater than. This would have to have a greater than or equal to in order for these to translate the same way.
Okay.
Because at -3, that's when it actually equals 0. Does that make sense? We don't want it to be 0, we want it to be above 0. So it's got to be this or that. Okay. Log functions, here we go. Okay. So, a couple of things. Okay, I'm going to start over here. Over here on this side, you'll notice that it looks kind of like those exponential equations that we were talking about, right? Except when we did them last time, it was y equals a to the x, right? So, what's the relationship here if it's written like this now? This is the inverse. Very good. So when you switch the x and y, now we're talking about the inverse of this exponential function, right? But the problem with that is we like having nice equations for y. We don't know yet how to get this y by itself, okay? But let's write down, or highlight anyway, the restrictions. The base of the exponential function is never equal to 0. Okay. You know what? I don't think that's correct. Let's change this. a is greater than 0, and it's never equal to 1. Okay? We could have a base that's a fraction less than 1 in here. I think that's a typo. That should be switched around. Okay? But we can never have 1 because 1 to anything is 1, so it's not an exponential function anymore. Okay? So we have these two restrictions. Okay? And as a result of that, x has to always be positive. Just like over here where we had y, remember that these graphs, you guys, looked like this, right? And we had that y was always greater than 0 for our range. Well, now it's going to reverse. Now it'll be x that's greater than 0. Okay? You guys got that? Okay? We'll do these details in a lot more detail in a little bit. Right now, here's what we want to focus on. If this is the exponential version, exponential form of an equation, over here is the log form of the equation. Okay? One thing that we want to get really good at is seeing an exponential equation and being able to translate it into its log equivalent, or vice versa. If you see a log equation, sometimes it'll be helpful to write it in exponent form to see what's going on. Okay? Yes?
I thought the exponential version was y equals x.
The reason this is still called exponential is because we have exponents here.
So is this just a different way of writing?
Different way of writing the inverse.
But isn't the inverse along those?
Both of these are the same thing. These are one and the same. This is what we're talking about. So here's the original exponential function, right? And then both of these are the inverse. So typically we don't write it this way because we want to have y alone, right? Because usually our steps were to switch x and y, get y alone, and then that rule, that would be your inverse. Well, here y is not alone. Here it is. So a lot of times we like this version better. Okay? So look, it's very easy to remember. Okay? If I asked you what's the base over here, what letter would that be? A. A is the base, right? Looking over here, which letter is the base? It's still A. That little subscript. So the base does not change. Okay? We have a base A exponential function. Here we have a base A log. Okay? So the bases are the same. Number 2, and this is not highlighted here, but I'm going to make a big deal out of this, okay? Logs are exponents. Okay? They're really just exponents written in a different way. Okay? So if I asked you, here's a log, what's the exponent? Look over here, what's the exponent? A is the base. Where's the exponent for this? It's the y, right? It's literally the exponent. So if I asked you to write it in log form, you would say the log base is a, the exponent is y, okay? And this thing right here, it's not written down, but I'm going to write it down. It's called the argument of the log, and that's the other variable, okay? Yes. And it's not necessarily just x. It could be x plus 5. It could be x squared plus 2x minus 3. You know, it depends. But whatever is in the log, that is called the argument. Okay? And I've kind of hinted at this already, but the domain and range should make sense to you. Okay? Because if you look at the exponential, let's see if I can find it real quick. When we did exponential functions before break, okay? Oop. I guess we did that. Here we go. This is a better place to look. So here we did y equals a to the x right before we took off for break, right? What were all the domains for exponential functions? All real numbers. If we're doing the inverses of those now, those are logs. You got to remember that. Now it's not the domain that's all real numbers. It's what? The range, because everything flips around, right? So if you look at the domain, or I'm sorry, if you look at the range, See how it's reversed, right? And typically our range for all of these was 0 to infinity for all of them, unless we had shifts up or down, right? So now those ranges are the domains for the log functions. Does that make sense? Okay? This is some pretty complicated stuff, but if you can remember two basic things. Number one, logs are exponents. That'll help you when you're switching things around. And number two, that they're the inverses of these exponential functions. That'll help you decipher domain and range and know which one goes where. Okay? All right. Enough about all the details. Let's see if we can put some of this to use now. So I'll do this one with you guys, and then I'll let you guys try these two. This is an exponential form right here. How do I know it's exponential form? Number one, it doesn't say log, right? And we see what? Little exponents for all these, okay? So if I switch this to a log statement, this would be log. And then what's the base? Yeah, the base doesn't change, so that's still going to be 1.2. In the argument would be m. So we would say log base 1.2 of m. And then what do the logs always equal? The exponents. So it should be equal to 3. Yes?
So that's the log 1.2 equals 3. That's the inverse of that 1.2.
No, these are equivalent. These are not inverses. These are the same equation written in a different way. Unless you revert, well, first of all, we don't even have two variables here, but for example, if we had instead of a 3, we had let's say an x. If you rewrote it and it was log 1 base 1.2 of m equals x, that's not an inverse yet. It's still the same equation, just written differently. The x's and y's would have to reverse, right? This and this are the same exact thing. Okay? All we're doing here is taking this format.
So it's one form into another.
Exactly. That's all we're doing right now.
But they're both the logs.
Well, they both could be written as logs, yes. I think once we finish, it'll make more sense. Okay. All right, try these two. Log base what? What goes in there? What's the exponent? All right. All right, Sam, you look thrilled.
I'm so excited.
How do you write this in log form?
Log. And then
So base e. I want you guys to get in the habit of
base e
of.
of 9 equals
Very good. Jordy, what about this one over here?
Log basis A,
Uh-huh.
which is 24.
Mm-hmm.
And then equal 4.
Yeah. Very good. Makes sense? I mean, honestly, if you say no, that's okay, because it shouldn't yet. You should have some vague idea of how things are related and where they go, but you're not going to have a full grasp of how these things work until we complete the unit. Okay? But can we at least remember how to switch them? I hope so. Here's something that we should write down that's also not, it's kind of just in there. But let's add this up here. Log base e. Like this one right here. You see these two buttons on the calculator? Let's see if I can. You got a regular log, and then this is called a natural log, right? Which of these two has a base e related to it? The natural log, ln, right? Because you see in blue, what does it have right above it? E to the x. Do you remember how we talked about in the calculator that e to the x and ln are right next to each other because those are opposites or inverses of each other, just like square and square root, right? So when you see log base e, you need to remember that it's the same thing as just natural log, ln. I know the letters are flipped, that's because it's a translating thing in English, but okay. Natural log, same as log base e, okay? The other one that's not on here is the other button on the calculator, okay? The regular log button, sometimes it's called a common log. What base is attached to this one? 10. So log base 10 is the same as just log without any base written there. Kind of like, I always like to compare it to something that you've seen before. How do I know that this is not a cube root or a fourth root or a fifth root? There's nothing there, right? What number is really there, though? Yeah, there's a little 2. We just never write it because those are the most common radicals that we see, right? Same thing here. Log base 10 is a really common log, and for that reason, a lot of times you just won't see that 10 written, but you need to know that it's base 10. Make sense? Try these 4 real quick. Now we're going the other direction, switching it from log format to exponential format. Yeah. You missed this, but you probably remember.
I kind of did. Yeah.
When you start with these, you guys, I always ask myself, what's the base, what's the exponent? Because then there's no choice for what else needs to happen. What's the base here? A. What's the exponent? 5, right? Because remember, logs are equal to what? Exponents. Logs are equal to exponents. So if it's equal to 5, that means it's a to the 5th. So what does that have to equal? That's it. Make sense? Okay. What's the base here? Very good. So 10 to the negative 8 equals d. What's the base here? Okay, and also if you see it written this way, you do it exactly the same. Okay, so whether you see ln or log base e, it's e for the base. What's the exponent? Negative 3, and then it's going to have to equal the argument, which is b. Okay, last one here would be, very good. Okay, just some basic background stuff. Right now we're just focusing on switching things from one form to the other. Okay, let's turn the page. We're going to step it up a little bit, ramp it up. We'll do these together. Here we're also changing from log to exponential form. Okay. One thing I want to point out here is to make sure that the log portion is isolated or alone. Like here, there's no number in front of the log and there's nothing after it. Do you see what I'm saying? So right away we can switch this. What's the base? What's the exponent? And that should equal now y plus 3. See how that works? Okay. Here, do you see numbers after the log? Are you sure? Really sure?
After, yes.
There's a plus 1 after it. This plus 1 is not inside the log. Does that make sense? What would you have to see for it to be in the log? Yes, there'd have to be parentheses here. Okay? So here, before we start switching things around, we're going to subtract 1 first. So now it's ln y equals x minus 1. Now that the log part is alone, now we can switch it to exponential. So what's the base? E. What's the exponent? X minus 1, and that's going to equal y. ln is always base E. So whether it's written there or not, you just need to remember, if it helps, put that little e in there because that's really there. Just don't really need to write it. Okay? What do we do first here? Subtract 7. Very good. So once I subtract 7, if I put it in exponential, it's what base? To the x minus 7 equals y minus 2. Good. Right now we're not solving anything yet. We're just getting really good at switching it. Okay, because that's going to be a big part of solving these eventually. Here we got a couple of things going on. What do I do first? Add 3. So it's x plus 3 on the right. And then we can get rid of that negative by dividing by negative 1. So now it's log base 3 of y. And we can just make all of these negative then, right? Negative x minus 3. And now we can switch it finally. So what is it? Good. So we've gone from very basic to slightly more difficult to here's about as hard as it's going to get, where you have to actually do a few things first. But any questions on that? Okay. So now these can be really done without a calculator, but I will show you how to do these on a calculator eventually too. When we're evaluating logs, okay, there are some basic steps that you can do if you don't know how to do it. Okay, I'm going to introduce this an intuitive way, like where you kind of can probably look at it and figure it out without doing too much work. Okay, here's how I would approach A, and then I'll show you kind of like the algebra behind it. Okay, what are logs equal to? Exponents. Don't forget that. Logs are equal to exponents, right? What's the base here? So this is really saying 2 to what exponent is 16? In other words, what's the exponent that changes a 2 into 16? Well, let's see. 2 squared is not 16. 2 cubed is still not 16, right? What would it be? 4. Okay? So the answer here is just 4. Now, if that's too much to do in your head, here's how you would do it, okay? You'd start by, I'll just follow these steps. Write it as an equation equal to y, or x, but we'll use y. Now we change this equation to exponential form. So it's 2 to the y equals 16. And now these are equations that we did almost a few weeks ago. You got to make these so that they're the same base, right? So 2 to the y, and then 16 is 2 to the 4. Does that make sense? Remember that once the bases are identical, the exponents must be equal to each other. And that's how we get 4 for our answer. Okay? Now, on a calculator, let's see. Isn't there? Okay. So on the calculator, if you go to alpha and then the y equals menu, remember how we can do some pretty nifty things there? If you go over to where it says func, which is function, now it's got several different things that are very frequently used in the calculator. First one's absolute value. Now we got some calculus in the middle, and then what does this say? Log base. Let's see what happens if I do that. It puts it in there exactly in the format that we're seeing some of these, right? So now we would just fill in log base 2 of 16 and bam. Okay? So pretty easy to do on a calculator. Alpha, y equals, and then you go over to the second menu, the function menu, and then you should see a little log base option. Everybody got that? Okay. So look, if all else fails, it might take you a little longer, but should you be able to get all these perfect on a test? There's no reason not to, right? Even if you like don't remember how to do it by hand real fast, you can still type this in the calculator. Okay? Now, here's how I would do, like, if I'm not using a calculator, here's how I think about it. First of all, this 3 turns into a fraction. To me, that means the exponent's got to be negative. Right? Because what does a negative exponent do? It flips it over, so it's 1 over something now, right? And so how do I make a 3 into a 27? 3 to the, it'd be to the third, but negative because it's 1 over. Does that make sense? So in your head or intuitively, that's how I would know, well, 3 to the third is 27. If it's 1 over 27, well, my exponent must be negative then, so it's negative 3. Okay? If you do it the algebraic way, it's 3 to the y equals 1 over 27. 1 over 27 gets rewritten, so it's 3 to the minus 3. And now you see y and negative 3 must be one and the same thing. Okay? Why don't you guys do C? You know what? Finish this. Example and example 6. Let's get comfortable using the calculators for example 6, especially if you want to try C and D without. Go for it, and then we'll be almost done. And for 6, let's go ahead and round to 2 decimal places.
What's the difference between a regular log and a natural?
There's no, I mean, they're both logs. It's just a natural log is one specific base. It's base E. Okay, here are the answers if you want to check.
I think I put 8 through the calculator.
Oh, what?
How do you type the eighth root in the calculator? Well, let's see. So you'd go natural log, and then
Oh, there's a natural log.
math. You go right here to where it says this little option here. And then now you can type in eighth root of e. However, I argue that if you know how to switch it over, it's a lot faster, right? What's the base here? The base is e. What's the exponent? Y. And what does it have to equal? It has to equal whatever's on the inside. And you remember that an eighth root of e is the same as 1/8 exponent. So right here we see y and 1/8 have to be equal. So 1/8 is the answer. Yes?
For A, I keep getting a different answer. I get 1.61.
Oh, let's see what happened. Natural log of 5. Oh, hold on a minute. My little marker covered up the 1 and I didn't even... I think I did 5/3 instead of 15/3. Thank you. So it should be 1.61. Is that what I did? 5/3? I hope so. Yeah, I didn't see the 1. Okay. Any other questions on those? Yes?
Wait, how do you type the other, with B?
B? So well, you can just use the log button. It's base 10, right? If you don't see a base, because log base 10 and just regular log are the same thing.
Oh, yeah, you're right. That's 23. Can I just type 23 to that?
Yeah. That's how I did it up here.
And then divide again by
So if it's highlighted up here in my calculator. That's how I typed it in.
negative 20.
Yeah. This making sense, you guys? Okay. The last part, which we're barely going to have enough time for, but this is the reason we reviewed inequalities, is finding the domain. Okay? When we asked you to find domain earlier, up until now, you really only had to know 2 scenarios, right? If you saw a fraction, you should know immediately what that means for the domain, right? What do you think of when you see fractions? What's the issue? What's not equal to? The denominator cannot be 0 when you see fractions, right? If you saw a square root, what did we think of right away? Has to be greater or equal to 0, right? Now we have a third one, okay? The argument right here, the input, the argument, has to be greater than 0. It's almost like the square root issue, except we don't set it greater or equal to. It's just greater than 0. So whatever you have inside of the log, whatever's on the inside of the log, all you do is set that greater than 0, and then you solve. You guys see kind of why we review those inequalities now? Okay. What's x here? X is greater than -3. That's the domain. Okay? As long as you can remember to take the stuff on the inside of the log and just make it greater than 0, solve for x, that's all you got to do to find the domain. Here all I have is x cubed is greater than 0. Okay? We haven't really talked about the cubic graph, but if you're not sure, if you graph it, what part of the graph is above 0? From 0 to infinity. So x is greater than 0. Okay? How are we going to do this one? x squared minus x minus 6 has to be greater than 0. And this is why we learned how to do this on the calculator now, right? You graph this on the calculator and you look for the part of the parabola that is what?
Less than, I mean, greater than.
So visually that would be the part above or below the x-axis? Above, right. So if I graph that real quick, x squared minus x minus 6. Okay, you can find the zeros pretty easily, but they're going to be negative 2 and 3. And so how would I write the parts above the x-axis?
X is less than.
Or